right, here is the second worded example we are giving for bearings. Slightly different type of problem. Will and Harry both leave Camp O at the same time. Will walks south from O for 10 kilometres, and Harry walks west from O for 8 kilometres. And then we want to know how far is Harry from Will, and what is the bearing from Will to Harry. Now, as always with these questions, we want to draw a diagram first. Pause the video now, draw your version of the diagram, and then check with what I'm about to show you. So pause now. Alrighty, here is the diagram that we will hopefully have. So you have your crosshairs at O, and then so that's where they've left from. So he's walked directly south for 10 kilometres, and we're going to label that point as Will. That's where Will's ended up. Harry walked west from O, so this is west, for 8 kilometres. We're saying this is where Harry's ended up, and that was 8 kilometres long. So we've set up the situation, and you'll notice that we do have a triangle happening here. Why do we have this length here as x? That is representing how far is Harry from Will. So you wouldn't say he's 8 kilometres plus 10 kilometres, because he's actually closer if you look at it this way. So this is like the as the crow flies distance. That's what we're looking for here. So we want to know this length x. What do you think we might do? Well, we've got a triangle. We've got an unknown side length and two known side lengths. We're not even interested in angles at this point. Angles won't help us. We're looking for good old Pythagoras. So we come over here, we redraw our triangle with the 8, 10, and the x, label them as our C for our hypotenuse and A and B for our short sides, and we do a bit of working. Let's just talk through this here. So we've got the formula, sub in our short sides, and x is our unknown. Figure out what these are equal to, so our 8 squared and our 10 squared. Simplify that again. This x squared hasn't changed. We haven't done anything with this side yet. Once you get here and you've got x squared is equal to a number, you're square rooting both sides. So your next line, you no longer have x squared, you have x. Please make sure that when you do your working that once you've got your square root, you are not still saying that that's x squared. Okay, so your square root of 164 is equal to x. And you put that in your calculator and it gives you, it actually gives you this here is the unrounded, so 12.80624, which I put there to practice our rounding. Want it to 2 decimal places because it wasn't specified as anything else. So 8's definitely there, and we're going, is that 0 going to stay a 0? Is it going to change to a 1? This next number is 5 or greater. So that means we're rounding this up. Okay, this number is closer to 12.81 than it is to 12.80. That's why we're using this. And we have our units, kilometres, because it's our distance here. Let's have a look back at part B now. Oh, we've got our nice worded statement too. Okay, that's what X represents. Okay, part B, what is the bearing from Will to Harry? So for that, we need to look at our diagram here. If you want to have a go at that, pause the video now. All right, so the bearing from Will to Harry, remembering that where it is from is where we put our crosshairs. So we're going to put some crosshairs here at Will, and we're measuring the bearing from here. So what is from true north, measuring clockwise around to that black line, what is that angle? That's what we want to know. Now, it looks a bit awkward to find out how can we possibly do that? Well, we can relate it to our triangle here. So we haven't got any information about these bits, so we know that's 90, 180, 270, and then a little bit more. But this, what's left over in here, this nice orange angle here, that's actually an angle in our right angle triangle that we have. So now we're looking at what's the angle? And we know the sides. So what's the angle? Kind of trigonometry problem. So we can set that up like this. All right, and we'll talk through this working now. So here is our triangle. You'll notice we have 3 sides, the 8 and the 10 and the 12.81, but that we've chosen to use tan. Think about why we might choose to use the opposite and adjacent rather than using the hypotenuse in this question. It's because this hypotenuse has been rounded. Okay, this is not it's not exactly how far away they are, whereas this 10 and this 8 are exact. So we're going to use those for any future calculations that we have. So using those, we're using 10, write our formula, sub in what we know, 8 over 10, trying to find theta, so we use our inverse tan here. So theta is equal to inverse tan of 8 over 10. In the calculator, that gives us this angle, 38.66 degrees. All right, now that we know that angle, we head back up to our diagram here and go, okay, well, this is 38.66 degrees. So to find this purple angle, all we have to do is the whole thing would be 360, and we've got to take off that 38.66, right, to find out what this purple bit is. Okay, so 360 minus 38.66 is what we're doing here. And that's what we've got here. We end up with 321.34 degrees true, and we have our final worded statement. And that's it. Make sure you put in your degrees true. There we go.